Hello and welcome everyone, and thank you for joining our webinar. My name is Sophia Olsson and I will be your host for today. So today we're going to talk about next generation HMIs, and with me today we have our own in-house experts on the topics. James Robnett, automotive expert and US VP sales here at Basemark, and Seth Nykamp, product owner and technical artist at Basemark. And before we start the webinar, I would just like to go through some practicalities. The webinar will be around 30 minutes long, and if you have to leave earlier, no problems. You will get the recording sent to your email just after the session. And if you have any questions during the webinar, please feel free to share them in the questions tab to your right. There's a questions tab. You can click there and write your question, or you can write the questions directly in the chat, and we will address them in the end of the session where we have this Q&A part. Yeah, all right. I think that was all from me. James, Seth.
Sophia, thank you very much. And hello, everybody. Yes, this is James Robnett. I'm talking to you from Detroit, Michigan today. I'm excited to share the latest and greatest from Basemark around our Rocksolid Graphics product. The agenda today, I'm going to do a quick introduction of Basemark as a company for those of you who may not know us. I then want to discuss some of the trends around the digital cockpit that are emerging and really informing our product development as we move things forward. I'll introduce the Rocksolid Graphics product, which fundamentally consists of our SDK development environment and our Rocksolid engine, runtime engine. We'll then move to Seth for some product demonstrations. And if there's time permits, we'll do some Q&A at the end. So away we go. The foundation of Basemark really begins with our expertise around real-time graphics and compute. We have long-standing relationships with most of the SoC providers that are now working in automotive. This goes back to our kind of legacy and origin story from our benchmarking product and expertise. But this allows us to build products that can take the best advantage of the features of these SoCs as we move forward. Basemark, as a company, has significant experience working with automotive OEMs, tier ones, other partners. We've delivered some exceptional products into the market over the past few years. We have plenty of references for those. For those who want to reach out, we can share more of that story with you. Of course, we have all the pertinent and relevant ISO certifications, as well as being TSAX 3 certified, which is fairly unique and important as we move forward, especially with our European partners. Basemark as a company is something like 100 people right now, and really the bulk of our employees are 3D graphics experts. So, of course, software engineers, technical artists, graphics designers, and part of our vision and our core is really to enable the industry to bring high-level in-vehicle experiences with low power and saving energy. This is a mission that comes down from the top and is very important as we move forward. We'll talk about why that's so important, but it's probably obvious to most of you. So the first mega trend, I guess I'd like to just touch on, again, this is something that we see every day in the industry, but the emergence of the software-defined vehicle is something that we're all, I guess, probably trying to wrap our heads around. We've got a new electrical architectures that are emerging, moving from a distributed edge-based architecture to zonal and ultimately central compute architectures. We've got new business models emerging, obviously over-the-air updates, firmware, application updates are going to be important, not only to customers, but to OEM business models moving forward. And they're counting on a lot of revenue to be generated by this, and we understand that, and we look forward to supporting that. And I think it's important to note that the traditional relationships and hierarchies are changing also. So traditionally, the OEM tier one partner relationship was very well defined, and I think now we're seeing some kind of seismic shifts there as OEMs maybe take more of their software development in house or start to work with other partners. So it's an exciting time, certainly for Basemark, and I think an exciting time for the industry as we move forward into this era of the software defined vehicle. Um, Again, obvious and probably doesn't need to be stated, but screens, more screens, bigger screens have just exploded in vehicles over the past few years. This happens to be a picture of the new BMW iX that actually Basemark had a hand in developing their new augmented reality video navigation system. You're going to hear more about that later. But with more screens, of course, bigger is better, yes, but that's a challenge. That's a challenge for the OEMs. That's a challenge for the traditional tier ones and other partners to deliver these beautiful, immersive user experiences to customers takes a huge amount of development, as we all know, and Basemark is trying to position ourselves to make that easier, faster, and stronger as we go forward. Another big trend that I've been watching, and I know is interesting to a lot of people, is this emergence of ADAS and autonomous drive data that is coming into the car. One of the key, I guess, requirements or guideposts for the designers in the vehicle is now to provide information that communicates how the vehicle is perceiving its environment and how the vehicle is really thinking to give the passengers and the drivers confidence that the vehicle senses everything in its environment and is operating in a safe way. So things like ADAS map data, cloud data, video data, radar, lidar, other sensor data, and not just the data, but of course the perception around that needs to be communicated to customers. And this opens up some really interesting use cases. And again, we're going to touch on some of those as we move forward. I think another big trend that we're seeing over the past few years is this concept of really gaming quality graphics now coming to automotive. There are some established players, obviously, who have started this process and come really from the gaming environment into automotive. Basemark takes a slightly different approach and starting with an automotive grade, automotive specific product, but able to deliver that same level of experience. And I think as new customers come in into the automotive, user space, they're used to this kind of graphical experience, and of course, we want to support that going forward. And that's a big kind of plank in our product development path going forward is to deliver these immersive experiences, but on value hardware again. I touched on this a little bit before, but I think this idea of video augmented reality and even point cloud augmented reality becoming mainstream is very exciting and very interesting. This data, there's a huge amount of data, and so the ability to combine the rich graphics with these ADAS data and autonomous data sets coming in is something that we took into account at the very beginning of the product development process. And we feel that we've made a solution that is going to make this easy and fast to prototype, fast to create a final product, and of course, very easy to target to to port to the target hardware and get a final product very quickly. This is really my last point, and I think this is just something interesting that we've all watched again over the past few years. There's this tension in the automotive world between the traditional legacy, trusted OEM suppliers, tier one suppliers, and big tech now coming in, whether that's Apple or Google or Amazon. I think we all love our phones, and these experiences are probably natural to us. I think there's still an argument whether it makes sense for OEMs to fundamentally commoditize the user experience inside the vehicle when the branding of the vehicle and the DNA of the vehicle is so important. And of course, the in-vehicle experience is the main signal to the customer about that brand experience. So I'm watching this very closely. I know we all are. Apple's recent announcement about being able to extend Apple CarPlay to multiple screens certainly caught everybody's attention. And where that lands and how that gets ultimately, I guess, utilized in the industry is going to just be something interesting for us to watch. So I'd like to now introduce the Rocksolid Graphics product to you very quickly. And of course, Seth is going to go into more detail. But Rocksolid Graphics is a tool chain development environment combined with the Rocksolid runtime engine. And the idea was, again, to use our strong knowledge of how to maximize and optimize the performance of rich graphics in the current SoC environment that's available to OEMs. Fundamentally, we start with the front end of a Blender development environment or other development environments that are very well known to graphical designers. We allow an easy connection to the Rocksolid engine to be able to run these projects very quickly, and of course allow for the quick porting to the actual target hardware very quickly. So again, the benefits here are using tools that are readily available and readily known by the designers that are working in this industry, but reducing the number of iterations and loops that are needed to create these products and ultimately getting to a very high value product quickly, being able to prototype, test that internally, test it with customers, and ultimately get it ported to the target hardware as quickly as possible. One of the benefits we've seen, again, with our kind of unique approach is very high performance of this solution, typically 2 to maybe 3 times faster than other graphical engines that we've tested in the past. And we look forward to sharing that data with our customers and partners in real time here as we reach out shortly. Again, the focus is really to enable the creation of these high value, immersive, emerging user experiences, video augmented reality, immersive heads up display, high end instrument clusters, and other combinations of these products. And the software development kit environment, as well as the engine, is optimized to deliver the best environment and the best performance for these types of experiences. I talked a little bit about the performance, and I don't want to go into this too quickly, but I do want to show that we do have actual data around comparing our solution to, in this case, OpenGL or traditional Vulkan SDKs. And again, this is there. We can share this data with you offline or in the future, but there is real data here, and this is real. And I think the ability to create these high-level experiences with a reduced memory footprint and faster startup times and maybe middle end hardware instead of very high end hardware has obviously proven attractive to OEMs as we bring this solution forward. Okay, I'm going to stop there and catch my breath and hand it over to my colleague Seth to actually walk you through some of the product here, some of the developments that we've done, and with that, Seth, I'll kick it over to you.
Hey, thanks, James. One thing I would like to start off by is demoing off one of our instrument clusters that we built here at Basemark. So let me just share my screen. Here is an instrument cluster that we built here at Basemark. This represents more of the workloads that you'll be seeing in the near future. And what's interesting about this cluster, it was made with Blender and then exported out from Blender to Rocksolid to render. And we do this by creating a Rocksolid Blender add-on. And what's significant about this approach is we can create real-time runnable assets and define the visual logic all from Blender. Our approach aims to bring like the tools the 3D technical artist already knows to develop the real-time assets for an instrument cluster. Our approach brings 3 benefits to the table. Now you can work directly on 3D cinematic production pipelines You have faster iteration speed and design consistency. At its core, it's useful rapid prototyping tool for 3D embedded graphics. So now 3D artists can now develop and import assets from Blender to Rocksolid with a click of a button. This means custom shaders, the logic that controls them, are all exported in just one click. So our approach bridges the gaps between cockpit branding and HMI implementation. So technical artists can now work directly on cinematic quality assets in Blender to create assets needed for the in-car digital cockpit experience. This helps with consistency and uniformity of the product brand across like multiple domains. So this is just kind of the representation of what you can do with our tool chain. This then gets ported into an embedded environment using.
Hey, Seth. Seth, let me ask you. Seth, let me ask you a quick question. So you've been in the seat where you've been at OEMs designing, these clusters and these experiences. So as the product owner, what was your reasoning for adopting Blender as kind of the front end environment versus creating a proprietary editing environment? What do you see as the real benefits there?
Well, right now, the main benefit is for somebody that's dealing with the HMI implementation process is this whole back and forth process that happens from one application to another application.
Right.
So an editor is very valuable for certain things, but what we're doing first is solving this iteration process and iteration problem with getting assets from a high-end production pipeline to an embedded pipeline. So to do that, I kind of have an example project here that runs through a classic example that you would find in the HMI world, especially for 3D artists. And one main thing is 3D artists always have to learn. They always learn a new program, or they're always learning multiple different programs to basically do the same thing over and over again, but in different ways because each application has a different philosophy and how they go about doing that. So what we're trying to do is just remove the need for more complexity of software programs, reduce it down to the essentials. And for HMI implementation, you really do need the tools that are here in Blender or in Maya or any other 3D content creation toolkit to create the assets in the first place. And then from there, you port it over and then recreate it all again in another software program. So instead of that whole iteration cycle having to happen over and over again with each new change or each new idea update, we just got rid of that process, go directly towards the tools that are needed for the graphical artist. So this is what we did here, and this is why we have this add-on for Blender for Rocksolid Graphics. So one thing I can do is just copy a new driver and drive now a material value with this custom property. And then I can also take this custom property and drive a rotation value. And now I have a needle rotating along with its comet tail, or the visual effect of having something update as, say, you increase your speed in the car. So this is a classic setup and an example that is always done for every HMI implementation process. So from here, I can just add some animation effects just to give some visual cueing of how this is working when we just export it out. So I'm just going to add some animation data to it on export so we can see it visualize and update in Rocksolid. So with a click of a button, I just exported this whole scene out from Blender into Rocksolid, and I have animation now driving that custom property. Now you can take that animation data and replace it with user input data, like from a CAN signal or something along those lines, and have that property now drive this speedometer. Now the artist has already set up, created the whole working connections for this graphic to actually run. And all is needed is an engineer to connect the input data into this controlling property. What happens there is, yeah, does that help explain the question?
Yes, thanks for that. I think that's very clear and a great explanation. I think let's move to the next project you wanted to show. I'm just looking at the clock here, but the augmented video reality stuff is super important, I think, going forward, and I want to make sure we have time to talk about this.
Yeah. So again, I just showed like one setup here, but this is now we're getting into more production and multiple different streams of production happening. And what's nice about this, our tool chain now mixed with engineers, this is all running and rendering with Rocksolid Graphics because it's a lightweight performance rendering engine. It's low memory footprint, so that means faster startup times. And that's what's really key, is to make sure your car is up and running as soon as possible, but yet able to handle the graphical workload that is needed for something like this. So here we have an inference engine, also finding objects in the scene off of a video. And so we have these objects that are being detected by an inference engine, points being generated based on this inference engine finding edge detections and line detections within the scene. And then we are generating geometry dynamically with Rocksolid Graphics to now take in these data streams and visualize them for the user. And that's what's happening here. And not only that, we can do that data stream and then add in a cluster on top of it. So now you can actually handle these high-end workloads. And what's great about Rocksolid is you get an API that can be, you can build an application once and then port it onto different multiple SOCs. So, and about the Blender tool chain and the mix of all this is, you can see here that we can actually simulate all this data instantly, or the data that comes in from what engineers are gathering for defining their how the inference engine's working and fine-tuning their data, and we can port that into Blender as well. And then as we port that data in, we can actually visualize it. An artist can now use this data and create the actual assets and design and making sure it matches to our expectations of what we would like this to look like. So we can now simulate data and do a parallel processing of implementation that is needed across the board to actually build a product.
Perfect. Perfect.
That being said, we do, with Rocksolid Graphics, we do have a smaller AR application as an example. So we can help get you set up with Rocksolid Graphics faster and have this AR set up so you can use it, tweak it, build it into what kind of application you need it to run in. So that's
so the Rocksolid application comes with kind of these preset libraries that people can use to get up and running and started with the types of applications we've shown today, right?
Exactly. And this is just a video of it, but I mean, I could run in real time too to demonstrate that as well. But this is just a video of what of the example that we have for Rocksolid Graphics in the AR project currently. So, yep.
Perfect. Seth, that's awesome. Thanks for taking us through that. Sophia, I'm looking at the clock. I know we're getting close to the end here. Just on behalf of Basemark, I want to thank everybody for hanging with us for this webinar. We hope to do more of these in the future as the product continues to mature, but we're looking forward to engage with OEM partners and tier ones and others as early, evaluation of the product, and we're of course looking for customer feedback as well, and that's kind of where we are right now. Sophia, were there any questions that popped up or anything that we should address before we end?
Yeah, a few things. There's some few questions here. Uh, what do you think about the gaming studios now trying to get their foot into the automotive industry? That's one.
Yeah, I look. I think that the traditional gaming engine suppliers have fantastic products, and obviously they have some significant traction in the market to date. But the Basemark approach was to create a gaming quality engine that started as automotive grade and can be run on value hardware and will have incredibly fast startup times, smaller memory footprints, and use less, GPU resources fundamentally. So I think we come at the problem from a slightly different direction. At the end of the day, I think we're able to provide comparable experiences to those kind of legacy providers, but certainly doing it in a different manner. And again, we look forward to discussing those details individually with partners as we go forward.
What would you actually say are like top three benefits of using Rocksolid Graphic? Uh, if you can like summarize it
I,
all.
I think Seth should probably answer that, but I think my learning here is the flexibility and the ease of use and the speed to get automotive grade applications up and running, and again the reduced resources that are needed to drive these applications. But Seth, you're the product owner, so maybe we can end with your comments here.
Yeah, I mean, really, the main benefit is the performance, and getting the performance for the user experience is the number one goal. And that's fundamentally what we are bringing to the table with Rocksolid Graphics.
Yeah,
Yeah.
perfect.
Clear. All right. I think we're about to run up this day. First of all, I want to say thank you for joining us for this webinar. And if you're interested in Rocksolid Graphics, if you want to learn more or even try it for yourself, when the time is right, visit our website and check out more from there. Yeah, but thank you for joining us, and we hope to see you next time. And have a great summer, everybody.
Bye bye.
Bye.
Bye bye.